Hi everyone, this is Srikanth, Assistant Professor of Triple Department. In this session, I am discussing the question bank problems on Module 1, that is Introduction to Electrical Circuits. The first problem, determine the equivalent resistance and source current. Here, we need to calculate the equivalent resistance between these two terminals, that is A and B. And we also need to calculate what is the source current. So for calculating the equivalent resistance, first we are removing the 30 volts source. Six ohms, 5 ohms, 3 ohms, 2 ohms, 5 ohms, 4 ohms. Here, when we take these are the AB terminals, we have to start from the other end of the circuit. That is, here we can see this 5 ohms and 6 ohms are connected in series. Here this 5 ohms and 6 ohms are connected in series. 5 ohms and 6 ohms are in series. So R equivalent 1 is equals to 5 plus 6, which is equals to 11 ohms. Now this 11 ohms will be replaced in place of 5 and 6 ohms. Now our circuit will become this is 11 ohms, 3 ohms, 2 ohms, 5 ohms and 4 ohms, A and B. Now if you see the equivalent resistance, here this 11 ohms and 3 ohms are in parallel. 2 ohms is in series with that parallel combination. Here 2 ohms is in series with 3 ohm and 3 and 11 ohms are in parallel. So here R equivalent 2, I am writing 2 steps here. R equivalent 2 is equals to 2 plus 3 is in parallel with 11, that is equals to 2 plus 3 into 11 by 3 plus 11, which is 4.357 ohms. Now let us replace the circuit with this 4.357. Now our circuit will become four ohms, 5 ohms and 4.357 ohms. This is our equivalent circuit we got. Now if you see this terminal, between these two terminals, here this 5 ohms and 4.357 are in parallel. That combination is in series with the 4 ohms. So 4 ohms RAB is equals to 4 plus 5 is in parallel with 4.357 ohms. 5 is in parallel with 4.357 ohms. So RAB is equals to 4 plus 5 into 4.357 divided by 5 plus 4.357, which is equals to 6.328 ohms. This is the RAB we got. Now we need to calculate the source current. Source current is equals to Vs by RAB. Here the Vs value given as 30 volts. 30 divided by 6.328, which is 4.74 amperes. This is the Is value for the given circuit. Next, we need to go with the calculation of R. If I1 value is given as 0.24 amperes for the circuit given below. Here, this is the I1, I2 values are given. Now we need to calculate the what is the value of R. So first let us write the KVL in loop 1. KVL in loop 1, that is minus 60 plus R into I1 plus 20 into I1 minus I2 is equals to 0. Here I1 value is given, that is 0.24 into R plus 20 minus 20 I2 is equals to 60. This is our equation number 1. Now let us write the KVL in loop 2. KVL in loop 2, that is 20 into I1 minus I2 plus 30 into this is I2 minus I1. This is the second loop, no? So it is 20 into I2 minus I1 plus 30 into I2 plus 120 is equals to 0. That is minus 20 I1 plus 50 I2 plus 120 is equals to 0. That is minus 20 into 0.24 plus 50 I2 plus 120 is equals to 0. Here I2 minus 4.8 plus 50 I2 plus 120 is equals to 0. From this we'll get the I2 value as minus 2.304 amperes. So we have got the I2 value. Now if we substitute this I2 value into the equation 1, let us consider this I2 value as equation 2. Substitute equation 2 in equation 1. Substitute equation 2 in equation 1. That is 0.24 into r plus 20 minus 20 into minus 2.304 is equals to 60. From this, here 0.24 r is equals to 9.12, where r is equals to 38 ohms. So this is the way we have to calculate any other parameter by using the mesh analysis. The next problem is determine the power across each element in a given circuit. So for calculating power, either we need to have the voltage across that particular element or the current flowing through that particular element. Here the elements are connected in series. So let us calculate the current, source current. So source current Is is equals to voltage divided by the resistance values. Voltage divided by equivalent resistance. Here 3 resistors are connected in series. So which is equals to 45 by R1 plus R2 plus R3, which is equals to 45 divided by 5 kilo plus 10 kilo plus 7.5 kilo, which is equals to 45 by 15 plus 7.5, 22.5 kilo, which is equal to 2 into 10 to the power of minus 3. So where Is is equals to 2 milliamperes. Now we got the Is value as 2 milliamperes. Now we need to calculate the power across the resistors. So power across resistor PR1 is equals to Is square into R1. That is 2 square into 5. Here 2 milliamperes. No? 2 into 10 to the power of minus 3 whole square into 5 into 10 cube, which is equals to 20 milliwatts. Now PR2 is equals to Is square into R2, which is equals to 2 into 10 to the power of minus 3 whole square into 10 into 10 cube, which is equals to 40 milliwatts. And PR3 is equals to Is square into R3, that is 2 into 10 to the power of minus 3 whole square into 7.5 into 10 cube, which is equals to 30 milliwatts. These are the power across each and every element in the given circuits. One is 20 milliwatts and 40 milliwatts and 30 milliwatts. Now let us go with the equivalent inductance in the given circuit. Here the equivalent inductance calculation, which is similar to the resistor calculation when they are connected in series, L equivalent is equals to L1 plus L2 when they are parallel, L equivalent is equals to L1 L2 by L1 plus L2. So here when we are taking these are the terminals, we have to start from the other end, same like the resistors. So here 40 millihenry and 100 millihenry are connected in series. 40 millihenry and 100 millihenry are in series. When they are in series, L equivalent is equals to 40 plus 100, which is equals to 140 millihenry. This is L equivalent 1. Now we got the L equivalent 1 in place of 40 millihenry and 100 millihenry. Now we are replacing these two inductances with a single inductance, that is of 140 millihenry. Now now here if you see, this 50 millihenry is in parallel with 140 millihenry. 50 millihenry is in parallel with 140 millihenry. So L equivalent 2 is equals to 50 into 140 by 50 plus 140, which is equal to 36.84 millihenry. Now let us redraw the circuit. Here 36.84 millihenry and 20 millihenry, 30 millihenry, 40 millihenry and 20 millihenry. This is A and B terminals. Now this 36.84 millihenry is in series with 20 millihenry. 20 millihenry and 36.84 millihenry are in series. So here L equivalent 3 is equals to 20 plus 36.84, which is equals to 56.84 millihenry. Now we got the L equivalent 3 as 56.84 millihenry. Now let us replace the inductances with 56.84 millihenry. Now our circuit will become Now if you see, these are the terminals. Now if you see, these are the terminals. Here if you can see, this 30 millihenry and 56.84 millihenry are in parallel. That combination is in series with 40 millihenry. Let us take L equivalent 4 is equals to 40 plus 30 is in parallel with 56.84, which is equals to 40 plus 30 into 56.84 divided by 30 plus 56.84, which is equals to 19.63 millihenry. Now we got the L equivalent 4 as 19.63. Now our circuit will become 19.63 millihenry and 20 millihenry. This is A, B. If you see these between these two terminals, these two inductances are connected in parallel. So the LAB is equals to 20 is in parallel with 19.63. 20 into 19.63 by 20 plus 19.63, 9.90 millihenry. This is our equivalent inductance for the given circuit. Now, this is a circuit given used to calculate the currents flowing through each and every element. Now, for mesh analysis, we are going to give the current directions, that is I1, I2, I3. Here, first let us apply KVL for loop 1. KVL for loop 1, that is minus 20 plus 4 into I1 plus 5 into I1 minus I2, which is equals to 0. Here 4 plus 5, 9 I1 minus 5 I2 equals to 20. This is our equation number 1. Next, KVL for loop 2, that is 5 into I2 minus I1 plus 2 into I2 plus 3 into I2 minus I3 is equals to 0. Now we got, that is minus 5 I1 plus 5 plus 2, 7 plus 3, 10 I2 minus 3 I3 equals to 0. This is our equation number 2. Now let us write the KVL for loop 3. That is 3 into I3 minus I2 plus 5 into I3 plus 6 into I3 is equals to 0. Now it is minus 3 into I2 plus 5 plus 3, 8 plus 6, 14 I3 equals to 0. This is our equation number 3. By solving equations 1, 2 and 3, we'll get I1, I2 and I3 values. I1 value 3.16 amperes, 1.68 amperes, 0.36 amperes. These are the values we got I1, I2, I3. And here current flowing through 4 ohms, 2 ohms and 5 ohms, 6 ohms. That is, let us consider this as IA, IB, IC, ID, IE, IF. Here IA is equals to same as I1, which is equals to 3.16. IB is equals to, which is same as the I2, because only one current is flowing in this particular branch. So that is equals to 1.68 amperes. And IC is equals to ID, because they are connected in series, which is equals to I3, that is equals to 0.36 amperes. Now IE is equals to, because it is in the downward direction, so I1 minus I2, 3.16 minus 1.68, that is equals to 1.48, and IF is equals to I2 minus I3, that is equals to 1.68 minus 0.36, which is equals to 1.32 amperes. This is the way we have to calculate the currents flowing through each and every branch in the given circuit. Now find the current in 8 ohm resistance in the following circuit shown in figure using Kirchhoff's laws. Either here we can go with mesh analysis or nodal analysis. So here we are having two meshes and one node. Two meshes are there, and we are having so in this, let us apply the KVLs in the loops, that is I1, I2. So KVL in loop 1, that is 10 into I1 minus 15 plus 5 into I1 plus 15 into plus 15 plus 8 into I1 minus I2 plus 5 into I1, which is equals to 0. Here this 15 and 15 will get cancelled. 10 plus 5, 15, 15 plus 8, 23 plus 5, 28 I1 minus 8 I2 is equals to 0. This is our equation number 1. Now KVL in loop 2, that is 8 into I2 minus I1 minus 15 plus 10 into I2 minus 25 plus 10 into I2 is equals to 0. So minus 8 I1 plus 8 plus 10, 18 plus 10, 18 plus 10, 28 I2 equals to 40. This is our equation number 2. By solving equations 1 and 2, equations 1 and 2 will get the I1 and I2 values. We got the currents as 0.44 amperes and 1.55 amperes. Now we need to calculate what is the current flowing through 8 ohms. I 8 ohms is equals to I1 minus I2, that is 0.44 minus 1.55, which is equals to minus 1.11 amperes. This is the current flowing through the 8 ohm resistance. Now determine the voltage to be applied across AB in order to drive a current of 5 amperes in the circuit by using star to delta transformation. Here in this circuit we are having two number of deltas. Here this is one delta, 2 ohms, 5 ohms and 3 ohms one delta, 5 ohms, 10 ohms and 10 ohms is another delta, and 4 stars. This is one star, second star, third star and fourth star. Here I am considering only the deltas. Here these two deltas are going to be converted into star. So here I am going to replace RA, RB, RX, RY, RZ. Here for calculating the star equivalent values, RA is equals to R1 R2 by R1 plus R2 plus R3, which is equals to 2 into 3 by 2 plus 3 plus 5, 6 by 10, which is equals to 0.6 ohms. RB is equals to 2 into 5 by 2 plus 3 plus 5, which is equals to 1 ohm. And RC is equals to 5 into 3 by 5 plus 3 plus 2, which is equals to 15 by 10, that is 1.5 ohms. Now the circuit will be replaced. Again we need to calculate Rx value, that is 5 into 10 by 5 plus 10 plus 10, 50 by 25, which is equals to 2 ohms. Ry is equals to 10 into 10 by 5 plus 5, 10 plus 10, which is equals to 100 by 25, 4 ohms. Rz is equals to again 5 into 10 by 5 plus 10 plus 10, which is equals to 50 by 25, which is equals to 2 ohms. Now we are going to replace the circuit with these star equivalent. Now Here, if you see between these two terminals, here this 1 ohm, 3 ohm and 2 ohms are connected in series, and 1.5 ohms, 2 ohms and 4 ohms are connected in series. So 1 ohm, 3 ohm and 2 ohms are connected in series. When these two are connected in series, R equivalent 1 is equals to 1 ohm, 1 plus 3 plus 2. 1 plus 3 plus 2, which is equals to 6 ohms. And R equivalent 2 is equals to 1.5 plus 2 plus 4, which is equals to 7.5 ohms. Here 1.5 ohms, 2 ohms and 4 ohms are in series. Now our circuit will become A, B. 2 ohms, 0.6 ohms, 6 ohms, 7.5 ohms. Now RAB is equals to, here this 6 ohms and 7.5 are in parallel. That combination is in series with 0.6 and 2 ohms. So I'm directly writing 0.6 plus 6 is in parallel with 7.5 plus 2, which is equals to 0.6 plus 6 into 7.5 by 6 plus 7.5 plus 2, which is equal to 5.93 ohms. This is the RAB we got, and we need to calculate if 5 ampere current is flowing through the circuit through the terminals A, what is the voltage applied across AB terminals. So voltage is equals to current into RAB. That is equals to, current is 5 amperes into 5.93, which is equals to 29.66 volts. This is the voltage across AB terminals. This is the way we have to go with the reduction of circuit by using star delta or delta to star transformation. Here a wire is carrying a direct current of 20 amperes and a sinusoidal alternating current of peak value 20 amperes. Find the RMS value of resultant current in the wire. Here IDC, which is given as 20 amperes, I peak IM value in the AC is given as 20 amperes. Here I RMS is equals to 20 by root 2. So these are the two currents which are flowing, IDC and IRMS, into the current. So the resultant RMS value, IRMS value is equals to square root of IDC square plus IRMS square, which is equals to square root of 20 square plus 20 by root 2 whole square, which is equals to 24.5 amperes. This is the RMS value of a current which is flowing through the wire. Now, a sine wave has a peak value of 25 volts State the following values: RMS value, peak to peak value, and average value. So here V maximum is given as 25 volts. Now we need to calculate the RMS value. RMS value is nothing but root mean square value. Here root mean square value is nothing but Vm by root 2, which is equals to 25 by root 2, that is 17.675 volts. And peak to peak value, is equals to, from peak to peak, it is from positive peak to negative peak, that value is 2 Vm, that is 2 into 25, which is equals to 50 volts. Now the average value is equals to 2 Vm by 5, it is equals to 2 into 25 by 5, which is equals to 15.9 volts. This is the average value which we are going to get. And these are the formulas which we are going to use to calculate the RMS, peak to peak, and average values for any input which is given. Now, a coil inductance of 40 microhenry and negligible resistance is connected to a 5 kilohertz supply. If current flow is 15 milliamperes, determine the voltage. So here the inductance value is given as 400 into 10 to the power of minus 6 henries, and the frequency which is given as 5 into 10 cube h, and the current is given as 15 into 10 to the power of minus 3, and we need to calculate what is the voltage across inductor. So for that, first let us calculate what is the reactance. XL is equals to 2 pi FL, which is equals to 2 pi into F value is 5 into 10 cube into 400 into 10 to the power of minus 6, which is equals to 12.57 volts. This is the XL value. Now we got the XL value where VL is equals to I into XL, which is equals to I value is 15 into 10 to the power of minus 3 into 12.57. So this is XL value is ohms. The units of reactance is ohms. 15 into 10 to the power of minus 3 into 12.57, which is equals to 188.5 millivolts. This is the voltage across the inductor. The next one is here at 240 volts 50 Hz AC supply is applied. A coil of 0.08 inductance and 4 ohm resistance connected in series with a capacitor of 8 microfarads. Calculate the following: impedance, current, phase angle, and active power. Here the voltage Vs is equals to 240 volts and the frequency is 50 hertz and inductance is 0.08 henries and the capacitance is 8 microfarads. So these are connected in series means and a resistance is given as 4 ohms. So these are connected in series means our circuit will be like this. Four ohms, 0.08, 8 microfarads. Here it is 240 volts. Now for calculating impedance, first we need to calculate what is the reactance of inductor and capacitor. XL is equals to 2 pi FL, that is equals to 2 pi into 50 into 0.08, which is equals to 25.13 ohms. Now XC is equals to 1 by 2 pi FC, that is equals to 1 by 2 pi into F value 50 hertz into 8 into 10 to the power of minus 6, which is equals to 397.88 ohms. Here, this is the XL and XC, where impedance Z is equals to R plus J into XL minus XC, which is equals to R value is 4 ohms plus J into XL value is 25.13 minus 397.88, which is equals to 4 minus J into 372.75, which is equals to square root of 4 square plus 372.75 square, which is 372 point 372.77 ohms. This is the total impedance across the circuit. Now here current is equals to V by Z, that is equals to 240 by 372.77, which is equals to 0.64 amperes. Now we got the current I, and the next one is phase angle we need to calculate. Phase angle phi is equals to tan inverse of x by r. Here tan inverse of the x value is, we got it as minus 372.75 by 4, minus 372.75 divided by 4, which is equals to minus 89.38 degrees. So we got the phase angle. Now the active power is equals to Vi cos phi. Here the V value is 240 into I value 0.64 into cos phi cos of minus 89.38, which is equals to 1.66 watts. This is the way we need to calculate the active power. With this, we have completed all the problems in the question bank for module 1, Introduction to Electrical Circuits.